In this video, we're going to solve some problems for magnetic fields in current carrying wires. So let's set up an initial scenario. We're going to have a diagram below consisting of two separate wires in close proximity to each other. Wire A has a current of 2.5 amps and wire B will carry 0.75 amps. We're going to calculate the magnetic field strength B at point X between these two wires. Now the two currents run anti-parallel, 2.5 for A and 0.75 for B. X is 0.15 meters from wire A and 0.1 meters from wire B. We're also going to work out what happens to the wires. So let's determine the magnetic field direction. So using our right hand grip rule, our wire current is for wire A is flowing from right to left, meaning that our fingers denote that the magnetic field is flowing into the page at the top, denoted by the X, and flowing out of the page at the bottom, showing that with the dotted line. For wire B, we're going left to right. Now we've made a slight mistake here. Instead of going into the page, we should be coming out of the page. So we've got to swap these around. So basically we should have dots on top and X's at the bottom. So now we'll calculate the magnetic field strength. Now we're going to be using our normal formula, but what we're going to state is that wire A coming out of the page is going to be positive. So magnetic field strength BA is going to be denoted by the magnetic constant times the current divided by R. Now the magnetic constant is 2 times 10 to the negative 7 newtons per amp squared. I is 2.5 and R is 0.15 meters. So we substitute this into the equation and we end up with positive 3.3 times 10 to the negative 6 Tesla. So that means it's coming out of the page. Now wire B is going in the opposite direction. So as a result, basically we'll make this negative. So it's the same formula, K times I over R, where I is going to be 0.75 amps, R is going to be 0.1 meters. We're going to substitute that into our equation. Here we go, and we get negative 1.5 times 10 to the negative 6 Tesla. That means it's going in the opposite direction. So let's work out the net field strength. So the net field strength will be the magnetic field strength total will equal BA minus BB. Basically 3.3 times 10 to the negative 6 is the magnetic field strength for A, and 1.5 times 10 to the negative 6 is the field strength for B. We take it away because it's going in an opposite direction. The overall answer is positive, so it must be coming out to the page. Now what's going to happen to the wire? Well, wire B will be pushed downwards. This is because the strength above the wire is greater than the strength below the wire. So the magnetic field strength at X is greater than the magnetic field strength below the wire, so it's going to push down. For wire A, the opposite, the same is going to happen. It's going to be pushed down because the strength above wire A is going to be greater than that at point X. Okay, well I hope that makes sense, and you'll be able to see that this force basically is going to be paramount for our whole process. Thanks for watching.